Hello everyone, welcome to the course on solid state. So we are discussing about crystal defects. There we come to know about what is the meaning of crystal defect and what are the types of crystal defects. So the types of crystal defects are point defect and line defects. We are discussing about the point defects. So the point defects are further classified into three types. Those are stoichiometric defects, non-stoichiometric defects and impurity defects. So stoichiometric defects, they will not alter the stoichiometry of the compound. There we again classified those defects into how many types? Two types. Those are vacancy defect and interstitial defect. In today's video, we will study about the defects which are found in ionic crystals. So when we consider NaCl, ZnS, AgCl, AgBr, all those kinds of ionic crystals, how the defect is occurred in those types of crystals and what type of defects they are said to be, that we will discuss in this today's video. So in ionic compounds, as you have observed that in vacancy defect there is a missing of one particle and it is said to be vacancy defect. In interstitial defect, the particle gets accumulated in interstitial site. Now in case of ionic crystal, you will find the vacancy defect and also interstitial defect, but there the crystals should maintain the electrical neutrality. Means the net charge on the crystal should be 0, because whenever we consider the crystal, for example Na plus and Cl minus, that is NaCl crystal. In NaCl crystal, in order to maintain the electrical neutrality, always if one Na plus is there in the crystal, then there should be presence of one Cl minus. Means equal number of cations and anions will be present in that crystal. Now let us consider a crystal which is having the cations and anions, that is an ionic crystal. So one is cation, another one is anion. So they are arranged in alternate manner. So that can be represented like this. Okay, it may be any ion. You may say that A plus B minus, okay, A plus B minus in such type of crystal. So in this crystal, if there is a missing of one anion, let us say one anion gets missed. Now there will be formation of an vacancy defect due to the missing of a particle at lattice site. There will be formation of defect. That defect is said to be vacancy defect. But as I have mentioned that in ionic crystals, there should be a maintenance of electrical neutrality. That means the number of cations should be equal to number of anions. So when the anion gets missed from this lattice site, what would be the number of cations and anions? 1 plus 2, 3, 4, 5, 6. 6 cations will be there. And how many anions are there? 1, 2, 3, 4, 5. 5 anions are there. 6 cations and 5 anions are present. Initially, before missing of anion, there will be presence of 6 cations and 6 anions. But now, one anion is removed. In order to, as it is an ionic crystal, in order to maintain electrical neutrality, another particle gets missed from this crystal lattice in order to maintain electrical neutrality. So whenever there will be missing of one anion, immediately another cation will get removed, or it will also moved along with the anion. So one of the cation will also gets removed. Therefore, the number of cations now becomes 5. So 5 anions and 5 cations will be present in this crystal in order to maintain electrical neutrality. So in ionic crystal there will be missing of equal number of cations and anions takes place, leading to the defect. That defect is said to be Schottky defect. One of the important defect, that is Schottky defect. Schottky defect. Schottky defect means the defect in which there is a missing of equal number of cations and anions takes place is said to be Schottky defect. Why that missing of equal number of cations and anions takes place? Because in order to maintain electrical neutrality. And here the examples which shows Schottky defect are NaCl, KCl, AgCl, etc. These kind of crystals will show this Schottky defect, and here the size of these ions are similar. Okay. The ions which are present in this Schottky defect are having similar size. Okay. The anions as well as cations are having similar size. Then only it shows Schottky defect. And also what happens to the density here? The density of the crystal gets decreases. Density gets decreases. And another important thing is, this defect is shown by the crystals which are having high coordination number. So this is shown by crystals having high coordination number. So coordination number means the number of nearest neighboring particles surrounded to each constituent particle. That means when there is a huge number of particles are there around the around the constituent particle, then only this kind of defect will be observed. If there is a presence of a very low coordination number crystal, we can't find this Schottky defect, because if more number of anions and cations are missed, then the crystal gets collapses. Okay, and hence it will be observed only if the coordination number in that crystal is high. So these are the certain factors which affects the Schottky defect. The anions must have similar size and density decreases, and coordination number should be high. Examples are NaCl, KCl and AgCl. Another type of defect which is observed in the ionic crystals are Frenkel defect. Frenkel defect. So what does this Frenkel defect means? Consider the ionic crystal which is having the formula AB, where the alternate cations and anions are arranged. Okay, so this is the ionic crystal. Now in this crystal, alternate cations and anions are arranged. Now what happens is, one of the ion which is present at the lattice site will move to this interstitial site. As you all know, the empty space which is present between the particles is said to be interstitial site. So due to certain change in pressure or temperature, the cations gets dislocated from their original site to interstitial site. Okay, this is interstitial site and this is the original site where the cations and anions are actually present. From that original site, the cations gets dislocated or displaced to interstitial site, and this A plus will move to this interstitial site. So thus, when it moves here, the defect is arised in this crystal because arrangement becomes irregular, and this kind of defect is said to be Frankel defect. And another thing, remember here, only cations gets dislocated from their original site to interstitial site because the cations are having smaller size and thus they can easily occupy the interstitial site. As while explaining the calculation of finding the formula of the compound, there I have told you that the anions are larger in size and cations are smaller in size. So here also the cations are smaller only, and those cations gets dislocated to their original from original site to their interstitial site, and such kind of defect is said to be Frankel defect. Okay, it may move here, here or here or here, whatever it may be, it should move to the interstitial site from its original site. This kind of defect is said to be Frankel defect, or this defect is also said to be dislocation defect. Dislocation defect because it will get dislocated from its original site. Hence it is also said to be dislocation defect. Now what are the characteristics of this Frankel defect? First, what happens to the density of this crystal? The density of the crystal, will it increases or decreases? As you observe here, the particle is not either removed or added. The number of particles will remain same, only the position of the particle has been changed, and hence the mass will remain same and volume will also remain same, and hence the density will remain same only. The density remains same. Then this kind of defect can be found in the crystals having low coordination number, because when the crystals are having low coordination number, that means the number of particles which are surrounded to each constituent particle will be less, and hence there will be presence of an empty space, that is nothing but interstitial space. Thus the cations can easily move to the interstitial site due to the low coordination number. Hence Frankel defect can be observed in ionic crystals having low coordination number. And the examples for Frankel defect are AGBR, ZNS, etc. So these are the examples for Frankel defect or dislocation defect. Okay, so this is all about the crystal defect in case of ionic crystals.